let's talk. So first thing we're going to do is we're going to talk about terms. Anytime you're talking about terms of a polynomial, terms are simply the parts, the pieces, all the different things. So terms all have a degree. For instance, 3x, you look at 3x, that means 3 times x, that is a term. I hope that glare is not too much for you. So I'm looking at that, terms, 3x is a term. That term has a degree. The degree of that term is the sum of its exponents. In this case, x doesn't really have an exponent, but he is to the first power, which means he is a first degree term. If I do something like this, suppose I have like 5x to the fourth. Now I have a term that has fourth degree because his exponent is 4. If I were to have something like 3x squared y to the fourth, now what I have is I have more than one variable, which means I have to sum those exponents, which in this case is 6. So that means he is the 6th degree term. Last but not least, if you have something without an exponent, and we call those constants, we have something like 7. He has no exponent with him. He has no variable to have an exponent. That means he is a 0 degree. If you remember back to your exponent rules from Algebra 1A, you will understand this because technically we could put any variable in here to the 0 power because that just has a value of 1, and 7 times 1 is 7, so that would equal, so he is a degree of 0. Now, why do I go through all that? We're going to talk about polynomials. Polynomials, ladies and gentlemen, are many numbered expressions. I'm going to put that, well, I'm not going to bother with that definition. You can write that down if you want. Polynomial is just that blanket term that stands for any type of expression you're working with. 3x plus 4, polynomial. 7a squared b cubed minus 2ab plus 5, polynomial. It just means there's many terms, 3x and 4. It's got 2 terms, it's polynomial. This has got 3 terms, it's polynomial. I can fill this with a whole bunch of terms being added and subtracted together, polynomial. That's all it is. So what we're going to do is we're going to talk about the standard form and the degree of a polynomial. Standard form and degree go hand in hand. First off, the degree of a polynomial is the degree of its highest term. Let's talk about that. Let's put something up here like 4x to the 5th minus 7x plus 1 plus 4x cubed. That's a polynomial. Got a whole bunch of terms. 1, 2, 3, 4 terms. Great. Now, if we look at the degrees of those terms, that will help us find the degree of the polynomial. The degree of this term, well, he is a 5th degree. Why is it a 5th degree? Because his variable has an exponent of 5. Then I have this 7x here. That guy has a degree of 1. Why is he a degree of 1? Because his exponent, well, it's technically 1. We don't usually put it in there, but he's a 1st degree term. Then I get to my constant. Of course, my constant right here, he has none with him. Technically, x to the 0 power, like I talked about before. That means he is a constant or he has 0 degree. Then the last guy right here, he has an exponent of 3. That means he is a 3rd degree term. So as I look at all the degrees of those terms, I take the highest, 5th. That means that this is a 5th degree polynomial. Additionally, if I want to put this in standard form, what I will do is I will put it in descending degree form. Meaning, I will reorder those terms in that polynomial to be in descending degree form. So all I would do is take this guy and say, okay, well, the highest degree in here was the 5th. That's why he's a 5th degree polynomial. That means he will go first. Then the next highest is 3rd, so he will be plus 4x cubed. Then the next is this first, which is the minus 7x. And the last, of course, is the plus 1. So all I did was take that polynomial, put him in this order, which is called standard form because he's descending degree, 5, 3, 1, 0. And I will now state that that is a 5th degree polynomial because that is the highest degree term in there. That's it. That's all it is to put it in standard form and mark the degree of it. Let's do one or two more, make sure we're okay with this. If that makes sense to you when I put this guy up there, if you want to pause the video, try it on your own before you see the result. Yeah, cool, try it. So let's take, I don't know, 7 minus 4a to the 4th plus 3a minus, I don't know, 2a cubed. So the first thing we want to do is we want to put this in standard form, and then we want to get the degree of the polynomial. So the first thing that we're going to do is we're going to identify the degree of each one of those terms, and hopefully at some point you won't have to write this. You will actually just go down and put it in standard form. So degree of this guy is 0. Degree of this guy is 4. Degree of this guy is 1. And degree of this guy is 3. So now let's put it in descending order. 4th degree term, negative 4a to the 4th. Notice the sign in front stayed. 3rd degree term, also minus 2a cubed. 1st degree, plus 3a, and then my constant, and of course that guy's positive, which means it's plus 7. I now have this guy in standard form, 4, 3, 1, 0, degrees descend. And he has a highest term of 4th degree, which means the polynomial is a 4th degree polynomial. Cool? Hope that's okay. Let's do... Nah, I think we should be all right. Let's move on to what happens when we want to name these things. We are going to start naming these. So instead of saying, oh, look, I've got a 4-term polynomial to the 3rd power, or something like that, or 3rd degree, we're going to get some names with this. Remember, math is a different language. We want to be able to speak that language. So we are going to name these polynomials. And we are going to name these polynomials, not Bob or Jenny or things like that. We're going to name them according to two things. So we're going to make a little T chart here. So that the names come from either number of terms or from their degree. So, number of terms. If you have a polynomial and he only has one term, okay, let me put this over here. We only have one term. That means he is a monomial. Get it? Get it? Mono, 1. 2 terms. Binomial. Get it? Bi meaning 2. And 3, well, that guy is a trinomial. Like a tricycle. Tri means 3. Whoops, didn't get the I there. Okay? Then we go to degree. You know how to find the degree of a polynomial now. If you have a 1st degree polynomial, that guy is linear. You should know that. We probably never explained that to you now as 1a, but you know that. Anytime you have a guy that's in y equals mx plus b form, that is a 1st degree polynomial. He is linear. He would generate a line. 2nd degree. This one's a little confusing. We'll talk more about it later. It is a quadratic, which a lot of kids look at me and go, quad means 4, why is that 2nd degree? We'll get there. We'll get there. 3rd degree, last one is cubic. So there it is. You need to know those, which means you have to commit those to memory, which means you should probably pause the video and write those down before we go any further. Pause, write it down. I'm about to erase. All right, so here's what we're going to do. We're going to combine everything that we've just done. I'm going to give you a polynomial. We are going to find the degree. We're going to make sure it's in standard form. Then we are going to name it. Are you ready? Here we go. We're going to, oh, by the way, we don't just end at 3 with all those things. Like there's further names, but for our purposes, we don't need to go beyond the cubic and 3 terms. So let's put 7 plus 4a minus a squared. Let's put that guy in standard form and give him a name. All right, standard form. First thing I will do is I will say, okay, this guy has degree of 0, degree of 1, degree of 2. So to put that into standard form, it would become degree of 2 first, then 1, and then 0. Now it's in standard form. Now we're going to give it a name. This guy has a power of 2. He is quadratic. He has 3 terms, so he is a trinomial. So my degree is, that comes first in our name, by the way. My degree is quadratic, because he's a power of 2. And he's got 3 terms, which means he's a quadratic trinomial. Easy enough, right? It's pretty simple. Once you know the degree and put it in order, you just need the number of terms in the degree, find it from that chart, but you got to commit to memory. Let's do another one. Let's do put that guy into standard form and give him a name. So if you look at this, let's try to do this without writing all that stuff and marking it all up. So if I look through this, I realize power 3, power 0, power 1. So power 3 goes first. Then my power of 1 would go next. Constants are always last. So that's going to be plus x, and then of course minus 1. So now we have this guy in the standard form, 5x cubed plus x minus 1. So now what we're going to do is we're going to put that guy, or give that guy a name. So he is going to be, well, he is to the 3rd degree. 3rd power is the highest term. That means he is cubic. He also has 3 terms, which means he is a cubic trinomial. You want to see the easiest one that happens to be the most difficult for students? That guy, 7x. Kids look at that and go, what's going on? And I'm like, well, you can't put it in order. There's no order when there's only one term. It's the only order you can have. Now let's go to naming him. Well, what's his degree? Well, he's a degree of 1. It means he's linear. How many terms does he have? 1. He's only 1. So he's a linear monomial. That's simple. So don't let the simple parts confuse you. Put it in standard form if you can or have to. 2, find its degree, give it its name, find the number of terms, give it its name. Done. That's Unit 1, Objective 1 for Algebra 1B. See you guys.